So welcome. I'm Craig Seppel, Regional Manager for Western Canada with Excell Battery. I'm here today. Joining me is Bob Fay, my counterpart in Houston, Texas, and our Director of Engineering, Mike McWillie. We would like to thank you all for inviting us into your offices and your homes today. We appreciate your time. It has always been a hallmark of the Excell Group to be customer facing, and we do so much enjoy this time when we can spend with each of you as individuals, getting to know you and your applications. It is through events like these that we do the work of listening for what the items are that we can do to help you achieve your next level. So once again, we really appreciate this time we can all spend together. Today, we'll take a look through Excell's Criterion gauging system. I will speak briefly on the history and advancements over the years, and Mike will take us through the technical specifications. Bob's going to do a nice demo of it all in action, and then we'll open up the floor to some of the Q&A that you guys have been posting throughout this conversation. So let's take a look at their next slide here. So let's take a walk through the past, shall we? In the days of yore, when the world was young, it became ever apparent that there was a real need to answer what seemed a very simple question, really. What do I have left in my battery? Can I get another run? Well, this very simple question came with the reality that we were operating in, what you all know are some of the harshest environments out there. Batteries would come back from the field with their badge of honor, the time-tested yellow and red paint marker scribbles on the side of the pack, 97 hours. And that paint was the capacity reporting of the day. So to take hold and wrestle this question to the ground, it was at this time that the Excell Group first introduced something we called our battery gauge, the BG. And the question was answered. It worked. It was simple to implement and operate, and life was good. A few years went by, and this wise person once said, if it ain't broke, it doesn't have enough features. And thus we undertook the design of the battery gauge 2. And not only did our engineers manage not to break it, they brought to you a whole suite of new features that the industry, that yourself were keen to have live within that battery, logging, shock, vibration, current, temperature, and a software interface to chart it all with. It was great. But it was only a couple of years, suspiciously, around the time my friend Mike McWillie came on board with Excell, that the thought came about that there were newer sensors, more powerful microcontrollers and memory that could withstand our harsh environments. We designed a new battery gauge, and this one was at a whole new level. With the need for your criteria to achieve this new bar for accuracy, the Criterion was born. Accelerometers in all axes were implemented. The ability to communicate with the tool in real time was added. The software package was re-envisioned. The whole system was pretty special. On this platform, we have carried on to where we find ourselves today with the Criterion 4. Just a suite of features that were just added in based on a lot of feedback and customer requirements. Power line modulation communications, if you only have the plus and minus available. Rotation RPMs was added so that we could see how fast things were actually rotating and what the situations in the whole stick slip, which can be a nightmare for us all when dealing with events and other things that can happen. And yet a further refinement to the software. So at this point, I would love to introduce you all to our Director of Engineering, Mike McWillie, who will run us through the system as it exists today and share with you all where things are at.
Thanks, Craig. Hi, I'm Mike, Director of Engineering, and I'm just going to go through kind of the technical specs fairly quickly. That there is a picture of the CR4 gauge, and It's able to sense, log, and record time of day with a real-time clock, voltage with the sensor. We have peak and average current, temperature, shock, vibration, rotation, and stick slip. And then from our time of day and current measurements, we calculate the capacity used. The interface to the pack is fairly simple. The gauge sits between the cells and the output connector, and we have two communication interfaces. The CAN bus, which is kind of the fastest, most robust interface, and then we have PLM if pins aren't available for CAN. Can we go to the next slide, please? Thanks. Power management. This has got a fair bit of effort to try and minimize the effect of the gauge on usable capacity of the battery. There are really three states of interest. There's deep sleep, which is our lowest current state for extended storage. As an example, with a typical pack max current draw, there's about 200 microamps, which means for a standard 29 amp hour pack, it would survive somewhere around 16 years. Sleep is logging enabled, but the gauge is inactive. Max current draw 1 milliamp, and apart from log entries of went to sleep and woke up, there's nothing written to memory there. And then active. We transition from sleep to active based on current being drawn from the gauge. That threshold is configurable, but once that's exceeded, you're in the active state. Max current draw is 5 milliamps. It's typically a little bit lower than that, but that is with all sensors running and writing log data at the highest rate possible. And again, just effect on battery capacity. So deep sleep, 16 years, sleep 3.5. And in a typical 300-hour run, you're using at most 5% of battery capacity. Acceleration is done with a 3-axis accelerometer. Two of them, X and Y, are used for radial, one for axial, and full-scale resolution 200G, RMS 140 for vibration. Bandwidth up to 400 hertz on both, and plus or minus about 10%. This is measured at a fairly high sample rate, 800 samples a second, and vibration gets, for radial, summed, filtered, and the max of the log rate is written to the log. For Z, it is just RMS filter and maximum during that log period written to memory. Shock also uses the same accelerometer data, but gets a different filtering mechanism. So shock is really the peak in that period logged to memory. So at that 800 samples a second, highest acceleration value recorded is the shock. Temperature. We have a temperature sensor on the board, and that is able to measure from -40 to 165, plus or minus about 2 degrees during the typical operating range. Temperature is measured a little more slowly, but still more than fast enough, 4 samples a second, and there's a moving average filter on that, which then gets logged to memory at the configured interval. Voltage range, good for 5 to 65 volts, and we can measure 16 millivolts of resolution, plus or minus 1% accuracy. And again, 4 samples a second, it gets filtered with the same moving average filter as temperature and logged to memory at the rate we choose. Current, able to measure from 10 milliamps all the way up to 6 amps with 1.2 milliamp resolution, 2% accuracy, and that same 400 hertz bandwidth as the accelerometers. Current gets a little more signal processing. So that one measurement gets used to generate 3 data points. The state of charge calculation, which is that 100 hertz measurement integrated over time. Then it gets averaged for the current that is logged just as current, and a peak detector of that period generates the peak current, gets logged. Rotation is done with a magnetometer, and we can measure anywhere from 3 all the way up to 500 RPM, plus or minus 5%. This is also sampled at quite a high rate, 1 kilohertz, and the rotation is filtered, integrated over time, and logged as RPM. Stick slip uses that same rotation data, and 3 paths on this one, min, max, average. And stick slip is the ratio of min minus max to average. So that's reported as a percentage. And finally, all of that gets stored in memory. We have 8 megs, which is good for about 4 million data points. Along with CR3, CR4 kind of expanded on the real-time communication options. We now have 2. There's CanOpen, which is full access to everything that is available in the app. And then there's a simplified basic CAN protocol, which only gives you a subset of the live data, but it's really easy to implement. On top of that, our firmware is also structured in a way that lets us plug in custom protocols for whatever's needed. Basic CAN, like I said, it's pretty simple. There are a total of 3 messages. They're sent out on fixed intervals. A GPIO pin on the gauge is used to switch between CanOpen and basic CAN. So when most people use this, they just send it out a pin in the connector and tie it low in the harness when it's plugged into the tool. IDs are configurable, so you can have up to 8 on the same CAN bus. You get 3 messages. Those 3 messages contain vibration, voltage, current, temperature, and capacity used on different intervals. But because the protocol is so simple, it doesn't support configuring the gauge or downloading of the log data. We do that in the app before integrating battery into the tool. And CanOpen. CanOpen is the same protocol that the app uses to communicate with the gauge. You have access to the full data set, everything including data download configuration, real-time data, and all of the data on the dashboard of the app can be enabled as PDOs on demand. If that's something that interests you, just reach out and we can set you up with those details. Just a couple of pictures of the gauge. CR4 went back to a single board, which really makes it a whole lot more rugged, and there's just less to break. All of that is interfaced to the app using our interface unit, which we call the IFU for short. There's a USB to serial connection in there, and then that handles both CAN and PLM. The app just switches between them automatically. Another feature that is quite useful in the IFU is power inject. If a battery is fully discharged, you can inject power from the IFU to the gauge, which lets you download the data regardless of how much energy is left in the battery. You also get DPass, which pretty much everybody needs. And then I'm going to hand it over to Bob for the app overview and demo.
Hi, everybody. I'm Bob. I'm, as Craig said, his counterpart in Houston. I think I know some of you out there. Anyways, I just want to go out over the Criterion app. As it says here, it's highly graphical, easy to use. That was our intention from the start, and I think we pretty much achieved that here. So I'm going to switch screens here to show a live view of the Criterion app. And hopefully I have it here, but anyways, the Criterion app is very graphical, easy to use. And what I have here is there's actually a battery hooked up. So it's showing the data of that battery, such as voltage, 28.2 volts, how much capacity used. This is a brand new unused battery, so there's really no capacity used at this point. But also showing temperature and current, and actually the vibration accelerometers are active and live, and you can tap on the battery and you can see the vibration accelerometers will reflect that. As Mike mentioned, there's a DPass feature in the app and the interface box. So if you click on the DPass button at the top, you're going to see parameters that are programmed into by default. But basically, you can start by clicking the start button, and you'll see a pop-up window showing the actual DPass. If you hover your mouse over the curves here, you'll see real-time voltage and current measurements. So this is designed to time out if it reaches the cutoff voltage or the recovery voltage that you're looking for. And you can also modify the DPass parameters to whatever you want by just, if you want to make the current higher, just click there and then hit start, and you'll see the current will climb up to 350 milliamps, just like I put in there. There is a ramp up time, as it says, but this is customizable to what you want to do, to how you want to DPass the battery. Let's go over to the configuration screen, and this is what you have to do when you receive the battery. You have to set up the battery to use in your tool. So you're going to see a screen like this once you go to configuration, and there's basically three things you have to do once you receive it. One, you have to set the clock. The battery is going to come to you set to Unix epoch time, which is like 1969 or 1970. So you want to set the time by clicking on that button. It'll bring the time to the current time that matches your computer time. And then you have to set the login interval by clicking one of the one of the menu items here that will populate the measurements, as you see here. So what this is showing you, if you click on typical, you're going to see all these numbers here, but this is telling you how often the gauge will write to memory. So voltage will write to memory every 5 seconds, current 5 seconds, and so on. You can actually change any one of these to whatever you want. And then you could save that for the configuration for your battery. Just want to point out this thing here, remaining log duration, means how long the memory will last with this configuration. So right now I have it set up so the the gauge memory will last 564 hours. You can see how if you change any one of these, it'll affect that number. So now it's 403 with changing the current recording interval to 1 second. We have these suggested intervals. You can also do a custom one, but these can be set up to work for your battery and your job, however you want it. So once you set up the log interval, you have to hit commit. So now the battery is committed to that log interval when it's used downhole. So after you do this, you can disconnect the battery, put it into your tool, run it downhole. Then when you bring it back, you hook it back up, go to the dashboard, you're going to see a download screen like this. This battery has like no data in it except for what it just did just now. So clicking that download button will show this little pop-up at the bottom. And when it's complete, then you can go to the analysis screen, which will have the data file that you just downloaded from the battery. We're going to pick this one, which I loaded in before, because it does show actual downhole data. It takes a few seconds to load up, but this is what you're going to see when you open up the data file. So it's showing each measurement color-coded, and by running your mouse across the screen, you can see each measurement at that point in time. If you click on this arrow over here, you'll see a legend that shows you what you're looking at with the colors. You can do a lot of things here, such as deselect different measurements by clicking this arrow, the check mark on the right. So you can remove whatever measurements you don't want to look at that point. There's an extreme box. If you click on that, it's going to pop up a window over here showing the max mins for what you see on the screen there. So for instance, this has showing a max axial shock of 161 Gs somewhere in there. You can also add multiple scales. So right now you're seeing only voltage and current showing on the screen, but if you click these boxes on the right, it's going to start adding the different scales. I mean, you could really add in all the scales that you want to see or deselect to your preference. There's a feature where you could change the scaling. So because of all these different measurements on the screen, it's kind of hard to show all the data at the scaling you probably want. So if we want to make this shock axial more pronounced, we can go over here and change the scaling. So hopefully that shock will show up maybe a little bit more, maybe have to do more than that. So if I do that, you're going to see the blue line come up a little bit higher so you could actually see it better than what it was before. I do want to point out some of our newer features, like Mike mentioned, we have rotation and stick slip. Rotation is now, you select some of these, but the rotation is the purple number, the purple graph right there. And it's right there showing 40 RPM. You can see where the rotation stopped and started by the way that curve goes up and down. We have a histogram feature where if you click on this histogram symbol at the bottom, a window will pop up like this, showing the different shock levels grouped by buckets. So right now I'm showing 124 shocks at 35G. This shows 2 shocks at 65G. So this is a good way to get a pictorial view of how much shock the battery went through. Over here, this little, I guess they call it a hamburger symbol. If you click on that, you're going to see different ways to download images. So you could download PNG, SVG, or a PDF document. Also, you could download a CSV file if you really want to look at the data, the raw data behind that. If I close the file, there's ways to export it. You can export it by clicking each one of these, this save file icon on the right, and it'll have a pop-up so where you can save the file to your hard drive. You can also import files. So say you download the file into your computer and you want to give it to someone else. You can export the file and then you can import the file by clicking that button and then import it from your computer hard drive. Let me open that file back up. I forgot to show one feature. We have an annotation feature where if you click this, you can type in whatever you want to call it, average shock. I don't know. Just trying to think up something there. And then click anywhere where you want to annotate that. And that will now show up on your PDF explorer. If you want to label things, you can do it wherever you want, like that. I just want to remind you, if you have some questions, please add in things to the question and answer box, and we will answer that later. So I think I pretty much went over most of the features of the app and the graph, and take you back to the presentation we had. Here it is. We do have a new version coming out. We're calling it version 4.2. This should be out very shortly. And some of the features I just want to go over real quick. One, we have a new dashboard layout, which basically, if you could go back, it's going to show active time. This is going to show you how many minutes, hours, or days that the battery actually discharged. It's not necessarily the same as capacity use. Capacity use tells you amp hours, but a lot of people want to know how many hours that the battery discharged. So this will help give you that tool to understand how many hours or days or minutes that the battery was actually discharging. Next slide, please. Status report. In the download menu that we were showing you earlier, you could download a status report, which is showing up in the next screen here. That will give you some key information about the battery. If you go to the next slide, please. So this will show active time, serial number, the peak temperature, peak radial, peak axial shocks. Next slide, please. This is probably our most important feature that we have, where it has memory erase. This will allow you to actually erase all the memory from the gauge. So if you want to use the battery multiple times and record at the highest resolution, you don't have to worry about using up all your memory. So you can erase the memory. It's not going to erase the capacity used. That'll still be part of the battery, so you never lose that part of it. But you can download. It's going to actually prompt you to download the data file. You could download each data file after every run, then erase that memory and start over with a fresh, clean memory. Next slide, please. Shock averaging. Sorry for the low resolution on the graphics here, but our current version, the shock averaging is probably not as descriptive as we would like it to be. So the next slide shows how we're changing that. So you will actually be able to see the peaks of the shock that occur while you're using a downhole. Next slide, please. And we also have, menu button optimized for smaller screens. We're increasing the histogram range up to 200G, and we have LAS file export feature, if that's something you want to look at. Just a real quick thing about, before we go to the questions, real quick about the Excell Battery. We've been a leading OEM supplier for of smart batteries for over 35 years. We do a lot of work in the oil and gas, as you probably know, and our specialty is demanding a very, very high temperature requirements for your batteries. So thanks. That's pretty much the extent of the presentation, but we have some questions that did pop up. And I'm going to turn this over to Mike, but what are some of the options that we can connect the gauge to the battery cell mechanically? Are we doing it via soldering or connectors? Mike, do you want to try to answer that?
Yeah, sure. We most often do that by soldering wires to the tabs that are welded. The gauge itself gets installed mechanically in the end cap of the battery assembly, and then wired between the output connector and the cell stack.
Maybe another question that's kind of related to that, Mike, is how many wires are needed for both the CAN version and the PLM version of the gauge?
Coming out of the pack, the CAN version needs at least 4, 5 if you want to do the basic CAN, since we need that 5th wire for the GPIO. PLM just needs the positive and negative.
Mike, I'm going to pick on you. I'm sorry, but there's another question that just came in. Can you explain in more detail what stick slip percentages represent?
Yeah, sure. They're really intended to kind of give you some insight into events that cause a lot of damage to the battery. The percentages are the difference between like a peak rotation and the average. So if during that logging interval, your average rotation is 10 RPM, but there's a period where it stops and then unwinds, that will show itself as a very high stick slip. And that high stick slip event is likely to have caused some damage.
Maybe I can answer this one. Can the gauge be reused? Well, the answer is basically no, because it is installed inside the battery, potted inside, and it is very time consuming and difficult to remove it, clean it up, and install it into a new battery. So it's designed to be a one-time use gauge only. Another question, does the software come with a cost? No, we provide the software free of charge if you buy a battery with a gauge. Another question, how do I obtain the Criterion app? Maybe Mike, you want to answer that one? How do you get the app?
Sure, yeah. You can just visit the Criterion page on our website, and there's a download form there that will always give you the most recent version.
How is the interface box connected to a computer?
That is by USB. It doesn't need external power or anything, just straight USB.
Another question, Mike, I'm picking on you as usual, but can data rate be changed?
In the standard protocols, the data rate is fixed, but if we were to implement a custom protocol for anybody, that would be a fairly trivial change.
And can you explain how to set the CAN ID?
Sure. Yeah. On the configuration page in the app, there's a box labeled Node ID, and what you set there becomes the CAN ID of the gauge.
Should we expose that GPIO in the battery, in the battery connector to configure it?
That GPIO only becomes important if you're using one of the basic protocol implementations. If you implement CAN open, you can pretty much just ignore it.
Here's a question we're always asked, but what is the temperature rating of the gauge?
The gauge is good up to 165 C.
On the new software version, does the new active hours represent discharge hours above a certain current threshold?
Essentially, yes. It represents the total amount of time that the gauge is in that awake power state, and that state gets entered based on current. So the intent there is to show you how long the gauge has been active recording and potentially downhole.
Wow, the questions are coming in, so I'm going to keep you going, Mike. So, what is the criteria to drive the Criterion in sleep mode? Can sleep mode be deactivated?
It could be deactivated just by setting the thresholds to be really low, like essentially 0. There are some consequences to doing that. Like specifically, the gauge will be in a higher power state for the entirety of its life, and it'll consume more energy from the battery. But that threshold is configurable, so you can either disable it altogether, or you can set it much lower so that it activates it at a current that better fits your tool.
And can you review the voltage ranges again?
Yeah, anywhere from 5 to 65 volts. So quite a wide range with the single gauge.
Are there any more questions? I think well, if there are questions, we would love to set up a demo for you. If you want to see a demo, please contact us at the emails below that you see here, or call your local sales guy like Trip in Houston. And we can arrange to have a demo come out to see you, show the gauge, show live use of the app. So that pretty much concludes our presentation here. We really appreciate you coming, and have a nice rest of your day.